So within our TCP/IP suite, we have two main protocols which we use and we call our communications protocols. Now, our communications protocols work on our transport layer, and they allow us to determine, there are protocols which determine how our packets are formatted, how they are sent, and essentially how we're going to take this data, break it up into chunks, and then send it to where it needs to go, and how that other end is going to take those packets and then reassemble them. So our transport layer is less about what's in the packets and more about how we're going to take those packets and send them from one place to another. Think of them as our delivery truck of choice. Our delivery truck doesn't really care what's in those packets. Our delivery truck, well, we care what's in them as far as whether we're choosing TCP or UDP, but our delivery truck is really what decides how big our boxes can be, how many shipments we need to make, and if we're going to have read receipts when we get to the other end, or if we have delivery receipts when it gets to the other end. So we have two main communication protocols within our TCP/IP suite. We have two main communication protocols when it comes to networking and computers. And this is TCP versus UDP. Now, our communications protocols, again, they work at our transport layer. This is our layer 4 of our OSI model. And what's the difference between our TCP and our UDP? Well, TCP stands for Transmission Control Protocol, and TCP is a connection-oriented protocol. So Transmission Control Protocol, and it's a connection-oriented protocol. And that's probably one of the biggest, most important factors of TCP, is that TCP is going to make sure that the packets we send get there, and they get there in the right order. And if they don't, or if they get corrupted along the way, we'll resend those packets. So if you think about the TCP/IP suite, if you think about communicating over the internet, one of our protocols is HTTP, loading web pages. Now, when we're loading a web page, we want to make sure that we're getting all the aspects of that web page. We want to make sure that we're getting all of the data to our computer properly and that it's loading correctly. That would be TCP, because TCP is going to say, the web server is going to say, hey, did you get this packet? Okay, cool, I'm going to send you the next one. And here's the next one, and here's the next one. And here's the way you put all those packets in order. And if any of them are corrupted, let me know, and I'll resend them, and things of that nature. So TCP is a connection-oriented protocol, which means it gives us delivery confirmation. It talks back and it communicates with the receiving party to make sure that it got it before it sends the next packet. Now, TCP allows us to have larger packet sizes, and this is because it has a larger header. It's larger packet sizes, and we also have a larger header, a 20-byte header. The reason we have such a large header is because we need a lot more information in that header that is essentially saying, okay, this is packet number such and such of how many packets I have to deliver to you, and I need you to send me back and make sure that this gets there. So our header is going to contain a lot more information. Now, a header on a packet is a part of a packet of data that includes information not necessarily part of that packet, but more information such as addressing information, where this packet is going to, information such as transmission control protocol information, such as which order this packet is, if you need to retransmit the packet, things like that. So our headers are additional information that we tack on to the beginning of our packet to help identify that packet. The rest of our entire packet could be encrypted, but that header we would still be able to, our routers would still be able to read, so we could move that packet along through the internet. If we encrypted our entire packet and then it hit a router that couldn't read that encryption, it wouldn't know what to do with it. It would just see it as a corrupted packet or an encrypted packet, but it wouldn't be able to read it. So we need a header on those packets. But because we have such a large header, we have a large packet size with TCP transmissions. So our TCP packets are numbered. All of our TCP packets have an order to them. So they have to have a number, because if the other end doesn't receive a certain packet, it'll say, okay, I have packets 1, 2, 3, wait, you just sent me packet 5. I didn't get packet 4. I need you to retransmit that packet. So that's why they're numbered. They also have retransmission, which means if the other end doesn't get a packet, it can request a retransmission and get a retransmission. Or if the other end does not confirm that it got a packet, then the sending end will say, hey, you didn't confirm you got this packet, I'm going to send it again. TCP is also a one-to-one connection. Because it is connection-oriented and we need to be conversing back and forth between our receiving party, if they received a packet and if they got it in the right order and if it was corrupted or anything like that, there needs to be a one-to-one connection. We aren't going to be using TCP to broadcast out packets. We're going to be using TCP on a one-to-one connection basis between us and another endpoint. Now, when we initiate a TCP connection, TCP also initiates something called a three-way handshake. Our three-way handshake is what gets this party started. Before we actually send any packets with our TCP protocol, we have our three-way handshake occur. So, on one side of the equation, we have our client, and then on the other end of the equation, we have our server. We have our web server. Or it could be a server and a client. It could be a client and another endpoint. It could be a server and a server. It doesn't have to be a computer and a server. It just needs to be two endpoints. You have an initiating side and the endpoint side. The initiating side is going to be whichever computer decides to start the connection. That's going to be the initiator. The initiator is the first part of our three-way handshake is that the initiator is going to send a SYN message, a synchronized message, also commonly referred to as a SYN message. This SYN message is our initiating party saying, hey, I need to synchronize with you and make sure that we can talk before I just start randomly sending you data. If our receiving party receives this properly and accepts that and decides it wants to, yes, initiate this connection, then it will send back to the initiating party a synchronize acknowledge. So this receiving party has said, okay, I acknowledge that I have received your first synchronization packet. So a SYN-ACK, synchronize acknowledge. And then our last transmission, our last part of our three-way handshake is our final ACK. That final ACK is an acknowledge from the initiating party back to the receiving party saying, okay, cool, I was able to hear you telling me back that you were able to talk to me. Well, why do we do a three-way communication? Why don't we just do a SYN and then a SYN-ACK? We need to make sure that the communication is clear both ways. If we just send one way, if we put a SYN to our receiving party, and then we just had a SYN-ACK from our receiving party, what if there's some sort of firewall block there? What if there's some sort of misconfiguration that is blocking that SYN-ACK? If our receiving party just assumes that that SYN-ACK went through, then if there was some sort of block there, it would be much harder to configure a way for those two parties to figure out what's going on. This receiving party would think that everything was fine. The initiating party would be the one that didn't know what was going on. So that's why we have this final acknowledge, because this final acknowledge tells the receiving party, okay, I got your response back that said you're good to go. So receiving party, our sending party says, hey, are you ready to talk? Receiving party says, yeah, I can hear you. Can you hear me? And then our initiating party says, yeah, we can both hear each other. We're good to talk. So then after we initiate that three-way handshake, after we verify that we have that connectivity between our 2 points, then we'll begin initiating our TCP communication. So our TCP, again, is connection-oriented. So we have to verify a connection. We have to maintain a connection in order for those packets to be delivered. Our final point for our TCP protocol is that we can push data as a stream, which means that once we identify our packet size for a TCP connection, we can take our data and just cut it up at the max packet size. We don't care if the point that we're cutting it at makes logical sense or not. So we're loading a web page, and we're sending all the data that they need to load that web page, and we have to break it up and say, hypothetically, that is we have 1,000 bytes that we need to transmit, and we're giving you a maximum of 100 byte packet size. Well, 20 of those bytes need to be the header. Then we have 80 bytes information, and then we take 80 bytes and we cut it. So we have 100 bytes of full information, and then we send that packet. We aren't sending any packets that are only halfway full, because we don't care where we cut it. We could cut the packet in the middle of a sentence or a middle of a logical stream of information, because it doesn't matter. Those packets are numbered, and if there's any corruption, they can be retransmitted. So we're just taking all of the bricks that we have that we need to have delivered, we're filling up the box all the way, and we're saying this is box number 1 that you need to open, and pushing it, and then saying this is box number 2 that you need to open, and then pushing it. And if they don't receive box number 2 or box number 3, then they can just ask us for that correct box back. We'll send them the box, and because they're numbered and in order, they just open it up and say, okay, this is my information. Wait, it looks like it looks like they filled up the packet and they stopped here. My next box should pick up right where it left off. So that's why we're able to just send that data as a stream with TCP. So TCP wrap up, biggest thing, remember, TCP is a connection-oriented communication protocol. When we're talking back and forth, it's connection-oriented.